Questions on the homework or any of the homework assignments so far? We good with all the homework assignments so far? I know the announcements are going to be coming on soon, but what we're looking at today are composite functions. So h of x, g of f of x. So there's two, and you can write these down. And one of them I refer to as fog, as it looks like FOG. So that circle with a hole in the center, just pretty much a circle, is composite. It's our notation for composite functions. And what this is telling us is that we're taking the function f of g of x. So we're going to take g of x, and whatever value comes out of it, we're going to plug it into f of x and get our final value. So we plug a value into g of x, find the output, and take that output and plug it into f of x. And that's really what this picture is showing. We plug a x value into f of x and get the output. And we take that output, plug it into g of x, and get our final one. So we have fog, and we also have golf. G of f of x. And as funky as this notation looks, with all of these here, these composite functions, we always work from the inside out. Inside out. So we always start with whichever's the most inside, the farthest inside the parentheses, and then work from there out. And as long as you focus more on that than trying to do everything all at once, we can work these a lot easier than they seem. So when we look at this first example, we're letting f of x be x plus 2. And we're letting g of x be x squared plus 3. Now, I wanted to change this because I found this to be a little bit nicer. First thing we're going to look at is not f of g of x. We're going to look at f of g of, well, it's not y. Let's use a. F of g of a. We're going to do f of g of a because this is going to make a little more sense the first time around, seeing this and seeing how this works, because we're going to work from the inside out. And part of the reason I'm changing it from x to a is because our first step in finding this composite function, is we're going to plug a into g of x. All right. So let's look at this here. So we're working from the inside out. So the first thing that we have, the farthest inside this, is g of a. And what we're going to do is in g of x is the function they gave us. Well, we replace the x with a. So in every place in g of x, we're going to replace each x with a. We'll still have the f because we're just focused on g of a. Well, g of x is x squared plus 3. Well, we replace x with a. So we have a squared plus 3. So we replace every x with a. We get that so far, yes? And this is part of the reason I've switched it from x to a, because if it was just x, we're going to replace every x with x. It doesn't change anything. It's the exact same thing. So I want us to see that we're plugging something in. We're actually plugging something in. So, well, our a squared is just a squared plus 3. Because once we plug it in, we're going to simplify. We're going to simplify it as far as it can. So, questions on this here, plugging in for our g of x, our a into that quantity. We good with this here so far? Yes? So far we plugged a into g of x and got a squared plus 3. Well, now we have f of a squared plus 3, yes? So we were given f of x. F of x is x plus 2. We don't have f of x anymore. We have f of a squared plus 3, yes? That means with our f of x function, we're going to replace every x in that function with what? A squared plus 3. So since it was x plus 2, it's now a squared plus 3. That was taking the place of x plus 2. Our a squared plus 3 replaced our x. So we now have a squared plus 3 plus 2. Questions on this here? Well, now we just need to simplify. We can drop the parentheses, telling us we have a squared plus 3 plus 2, a squared plus 5. So our f of g of a is a squared plus 5. And that's it. Questions on this here? Because really we're just continuously doing that same step each time. And again, I wanted to switch it from x to a so that we can see that we technically do it in that first step. Because if it had just been x, we replace every x with x. Well, we didn't actually. Visually, it doesn't change, but we did change it from x to x. It didn't. So a squared plus 5 is the answer. Because again, like most of the problems, this is straight out of the book. So this problem is one of the examples in the textbook. And the textbook's answer would change slightly. It wouldn't be a squared plus 5. It's going to be x squared plus 5. But that's our answer. Questions on this here? We ready for the next one? G of f of x. G of f of x. We're going to do one more of these with a just so that we can kind of see this here. G of f of a, and go through this here. And as I will tell you this right now, there's a good chance that this is not going to be x squared plus 5. It's going to give us something different. So again, with any of these here, I would highly advise to not try to do it all at once. Let's do it one part at a time. We always go from the inside out. So first thing we're looking at is f of a. Well, they still have f of x. It's the same as it was before, x plus 2. We don't have f of x anymore. We have f of a. So we replace the x with a, which means every x in the equation is replaced with a. So we have g of a plus 2. Now, it might be a question why I put parentheses around the a, because they're not needed. It's more of a habit for myself, and I think it's a good habit to be in, because if there's a power attached to that. If it had been x squared, well, we need it to be a squared. If there's a negative in front of it, it has to be applied to it. So I put the parentheses around there just in case, because if they're not needed, well, here they're not. We can just drop them. G of a plus 2. But if there's something we needed to apply to it, it reminds us to apply it. It gives us a way to have that plugged in. Questions on taking f of a? We feel good with this so far. Now we're looking at g of a plus 2. Well, g of x is x squared plus 3. Well, we don't have x anymore. We have a plus 2, which means every x in g of x is being replaced with a plus 2. So our x squared, so it's going to be a plus 2. We replace x with a plus 2, and our a plus 2 is being squared. And then we are adding 3 to it. Questions on this here? Well, the other one we could have just dropped the parentheses and been done, but here I can't just drop the parentheses around the a plus 2 because a plus 2 is being squared. A plus 2 is being multiplied by its self. A times a is a squared. A times 2 is plus 2a. 2 times a is plus 2a, and lastly 2 times 2 is 4. We have one last step and then we're done. Just simplify, yes. We're going to combine like terms. A squared is by itself. Well, 2a plus 2a is plus 4a, and 4 plus 3 is 7. So g of f of a is a squared plus 4a plus 7. So can we say that these two composite functions are the same? No, because f of g of a, the one we did in the previous problem, gave us, I think it was a squared plus 5. G of f of a gave us a squared plus 4a plus 7. Those are two completely different functions. Now there are some where the composites will give us the same value, and we call those inverses. If the functions are inverses, then their composites will give us the same thing. But we'll look more at those tomorrow. Questions on our composites? I can say we kind of get this. It is complicated and not complicated at the same time. But again, if we work from the inside out, take it one piece at a time. These are manageable, yes? I mean, trying to do this all at once and all in your head, that's too much. Because again, when I do these, I make sure, especially when I write these out, to do it one part at a time. Because trying to do all of this at once can be a bit much. Now this one here we'll leave as f of g of x. I'm going to rewrite it out because I don't think I have enough room to just extend out where f of g of x is. Now this time I'm going to leave it as x because I think we've kind of got a grasp at what we're doing, especially with the first step. And it's still the same thing. With g of x, I'm plugging x into g of x. So our g of x, which is 2x minus 4, we're going to replace every x in g of x with x. Well, yes. We just replaced x with x. It's still the exact same thing, yes? That's why I start the first two with a and not x, because replacing x with x doesn't change anything. Questions on how we got to f of 2x minus 4? Now again, we're going to evaluate this here. We're going to find this here. So we have f of 2x minus 4. Our original function f of x is the cubed root of x plus 1. Well, we don't have x anymore. We have 2x minus 4. So we'll take our cubed root, and we're going to replace the x with 2x minus 4. So instead of having x plus 1 inside, we have parentheses 2x minus 4, close parentheses, plus 1. Now the last thing we need to do is simplify. Well, we can drop the parentheses. 2x minus 4 plus 1. Well, our one-like term, negative 4 and 1 gives us minus 3. So our f of g of x is the cubed root of 2x minus 3. That's it. Questions on composite so far? So again, the biggest thing with composites is working from the inside out. We work from the inside out and take it piece by piece. So this one here, we're looking at g of f of x. Our first step is to plug x into f of x. Well, we're just replacing x with x. It just gives us the cubed root of x plus 1. Doesn't really change anything. We're just replacing f of x with its function. Questions on this so far? Now we need to do the same thing with g of x. But instead of g of x, we're now taking g of the cubed root of x plus 1. So every x in g of x is now being replaced with cubed root of x plus 1, yes? So this is the first time we actually have 2x. We've had it squared, but we actually have a number in front of it, yes? The 2 is still there because I'm not replacing the 2, we're replacing the x. So instead of x, we have parentheses, cubed root of x plus 1, close parentheses, minus 4. Because all we're doing is replacing each x. Now, so far, each one has only had one x, but if it had multiple, we would replace each x with the same thing. Last thing we need to do is simplify. We need to multiply 2 in the cubed root of x plus 1, which is, well, 2 times cubed root of x plus 1 minus 4. And that's as far as that goes. Because if we wanted to, we technically could multiply the 2 in, but it's not going to make it any simpler. It's just going to make it a little more complex, because we'd have to change 2 into a cubed root so that they have the same radical, and then multiply through, but there's no point. We just leave it as this here. X plus 1 is not simplifiable with our cubed root, so that is as far as it goes. Questions on this here? All right. Let f of x be 2x plus 7 and g of x be 3x plus 5. We want to find f of g of x. Since we're looking at g of x, well, first, we can just replace g of x with its function, which is because we plugged x into g of x, which is just giving us the same function back. Now, f of 3x plus 5, we're replacing every x with 3x plus 5. So just like the last one, we'll have 2 parentheses 3x plus 5 plus 7. We just replace each x with 3x plus 5. Questions on how we got to this point here? Now we are going to simplify. We need to multiply the 3x and 5 by 2. We're going to distribute that through. So yes, 3x times 2 is 6x. 2 times 5 is 10. And that's it. Questions on these composites? G of f of x. All right, guys, let's pay attention. Wake up. So, first thing we're looking at is plugging x into f of x. Well, if we plug x into f of x, we just get 2x plus 7. We're just replacing the function, which gives us g of 2x plus 7. Well, g of x is our 3x plus 5. So we're going to replace the x in 3x plus 5 with our 2x plus 7, giving us 3 times 2x plus 7 plus 5. And now we just need to simplify. We can distribute the 3. 3 times 2x is 6x. Plus 3 times 7 is 21. Plus 5. Be 6x plus. Now this one here, both of our x terms ended up being 6x, yes? But we're adding to it is a little bit different, yes? So it gives us still two different functions. They are not the same. G of f of x and f of g of x do not give us the same value. Questions on this here? How do we feel about composite functions? Pretty good. Probably be helpful to at least do one or two on your own to get kind of a grasp of it. Because I think by this point you all have realized, I don't know what it is, but I have some magic of making these look very easy on the board. The other type of composites that we're looking at is evaluating. We're going to evaluate it for a specific value. Now the first one it wants us to find is f of g of 3. F of g of 3. Now when we did our sum, our addition, subtraction, multiplication, division, we found f plus g of x, f minus g of x, f times g of x, f divided by g of x. Found the equation and then plugged it in. Here, there's no reason to do that. We're still going to do what we've been doing. We're going to work from the inside out. And the farthest inside that we have is g of 3. Well, we don't have g of x anymore because g of x is x squared plus 2. We've replaced x with 3. So what we have is 3 squared plus 2. Questions on how we got to this point? Now, the textbooks or different places differ on what we do now, because the next thing we could do is take 3 squared plus 2 and plug it into f of x for each x. That is a valid option. I prefer not to do that because that's just going to make the equation have a lot more pieces to it. Can we plug in 3 squared plus 2 in the calculator? Can we evaluate it? Yeah, there's no reason not to. Because 3 squared is 9, and 9 plus 2 is 11. We could do it by hand or let the calculator do it for us. Because plugging in 3 squared plus 2 into f of x is a little more complicated than just plugging in 11. So might as well just plug in 11 into f of x. You could keep going out. I'm going to drop down. Because now we're replacing every x in f of x with 11. Which gives us 3 times 11 minus 4. Can we plug that in the calculator? Yeah. Because 3 times 11 is 33, minus 4 is 29. So f of g, not negative 3, f of g of 3 is 29. That's it. Questions on part A? I think part B is also included on this here. So part B, well, before we move on to part B, are there any questions on f of g of 3? We feel good with this here? If you want, you can draw a line across the page because we still have part B to do. I'm going to clear that out. Main reason I'm going to clear it out so I still have the function notation. I'm not scrolling up and down the whole time. But our part B is g of f of -1. And again, with these composite functions, we're going to work from the inside out. So the first thing we're going to do is plug in -1 into f of x. So we're going to replace each f, or not each f, each x in f of x with -1. Guys, let's focus back in. Now at this point here, we can do this by hand or we can do it in the calculator. Either one works. So in the calculator, we type 3 parentheses -1 close parentheses -4. If we did this by hand, 3 times -1 is -3. And -3 minus 4 is -7. Either way, we get to the same point. Now we're looking at g of -7. And we're going to plug in -7 into every x in g of x. So we'd have -7 squared plus 2. And again, at this point here, you could type this into the calculator. Now, depending on how you typed it in, would give you 2 different answers. If you type this in, you should get 51. If you typed it in correctly. If you typed it in incorrectly, you will get -47. Because the parentheses around the -7 have to be there. Because what we're doing is multiplying -7 by itself, yes? -7 times -7, or -7 squared, is positive 49. And 49 plus 2 is 51. If you don't put the parentheses around it for the calculator, it sees it as -1 times 7 squared. Not -7 squared. It doesn't see it as one whole term. Does that make sense? So without the parentheses, it will square the 7 and give you 49 and then multiply it by the negative, which would give you -49 plus 2 is -47. So as I said, because if it's an odd exponent, the negative won't matter. As a -2 cubed is -8. The negative still stays there. So having it with or without the parentheses with an odd exponent doesn't matter. Even exponents, we need them because it'll make it positive. But if you're not sure whether you need them or not, go on and put them. Because if you don't need them and you put them, you'll still get the right answer. If you need them and don't put them, it will give you the wrong answer. But questions on these evaluating these composite functions? Let's see, what do we have left? Do we feel pretty comfortable with these here? Yes? I'm going to skip these 2, not because there's anything wrong with them, that they're easy or hard. I want to look at these 2 just because they're a little bit nicer with what I'm going to do, because I'm going to go a little bit off the note sheet for this. Okay? So we feel comfortable with this here, yes? All right, let's take it to an extreme. One, two, three. Let's do f of g of f of g of f of g of 5. Now, again, this looks like we've taken it to a whole nother level. It's harder than what we've done, yes? But again, what I started this lesson out with still holds true. We're going to work from the inside out, yes? So we have one, so FG, FG, FG shows up 3 times. 3 F's, 3 G's. And we're going to start with G of 5. This is also part of the reason I skipped the last 2, because I didn't want y'all to have to worry about dealing with absolute values and other functions. It's not going to make a difference, but F, G, F, G, F. Because the first thing we're looking at is G to 5, yes? So we're plugging the 5 into G of X and replacing every X in G of X with 5. That's there. 2, 3. Now, the parentheses after it aren't as crucial at this point. And if you're ever wondering how to make sure to keep track of them, kind of work your way out. The first one after the 5 is with the one in front of F. The next one is the one behind F and G. And just kind of filtering out. If you don't have the correct number, it's fine. It doesn't matter. It's more notation. But F, G, F, G, F. We have this here, 3 times 5 plus 5, yes? Can we type that in the calculator? Oh yeah, 3 times 5 is 15, plus 5 is 20. Is 1, 2, 3, 4, 5. Okay. But again, those parentheses, especially after the 20, are inconsequential. If you have them all there, awesome. If not, not going to make a big difference. Now we're looking at what? F of 20, yes? So we're going to plug 20 into our f of x. 4 times x plus 7, which would be 4 times 20 plus 7. And again, 4 times 20 plus 7, we can plug that straight into the calculator, yes? 4 times 20 is 80, plus 7 is 87. Questions on what we've done so far? Because all the problems, the main 2 we've done so far, that was it. That was our final answer and we're done, yes? Just repeat what we've been doing. Because now we're taking what? G of 87. Yeah, we just keep going and do it again. So now 3x plus 5. Now it's 3 times 87 plus 5. $266. Is this problem starting to seem less daunting than it started out as? Because it looked like we'd have to do a whole lot more than what we've been doing. It's really just same process over and over and over again. And most of it's less of us actually having to calculate anything out. We're just plugging it in. Let the calculator do the heavy lifting. Because now we're taking f of 266. Well, that'd be 4 times 266 plus 7, yes? Now, I'm going to grab a calculator again because $1071. Questions on how we got to f of g of 1071? Well, now we're taking g of 1071, which I believe is 3 times 1071 plus 5. Yeah. Syntax error. I need that 5. 3,218. Okay, I think 3,000. Oh, I said it backwards. Yeah, I'm glad we're double checking each other. 3,218. Are we still good with this so far? Because we have to do this one last time. We're doing 4 times 3,218 plus 7. $12,879. That's it. It is very tedious, but the overall concept, there's not a lot to it, especially when plugging in a value. Would y'all agree with that? But again, I wanted to do this. I always do one like this, especially in the notes, just to put it to that nth level to try to shake off some of the what might seem difficult about these, especially with evaluating. It's just repetitive processes. Questions on these here? Do we feel good with these? You're not going to have to state the domain of these here. We just need to find the composite. And this is going to be one of the few times you're going to be able to leave a negative exponent. F of g of x. Well, what's g of x? Okay, that's nothing different than what we've had. So the other part of this is to find f of 2x minus 4. Well, f of x is x to the negative 1. So if we replace our x with 2x minus 4, we'd have it in parentheses into the negative 1. You can leave it there. Because if we did want to simplify this, this one's actually not that bad. Because anything to the negative exponent has to be moved from the top of the fraction to the bottom. Which would mean if we did simplify this, well, since the whole expression, 2x minus 4 is to the negative 1, we just move the whole thing from the top of the fraction to the... So our final statement is 1 over 2x minus 4. I'll take it as 2x minus 4 to the negative 1 or 1 over 2x minus 4. Well, the same thing. Questions on this here? We ready for g of f of x? G of f of x, find the composite. Again, working from the inside out, so the first thing we would take is our f of x, plugging in x into f of x. Well, f of x is x to the negative 1. Now our g of x to the negative 1. Questions? Okay. That was our last one. Right here. Yep. Any other questions on this so far? We're good with this here. So now we're going to replace every x in g of x with x to the negative 1, yes? So we'll still have the 2 from g of x. But instead of x, we have x to the negative 1 minus 4. Now, if this had been like the last one where we have x minus 4 to the negative 1 with the 2 in front, you'd leave it there. Because the negative, or the 2 out front, so here, I'm going to add this. Wow, we're really out of time. We'd multiply through. But that's your final answer. That would be it. Okay? Wow. This is the assignment, especially on those last few. If you do have questions, ask. Please ask. And if you need, we can definitely look over those first thing tomorrow before we start the last piece. Let's see.